elimination reactions do not always happen in basic conditions. They can also happen under acidic conditions, under strongly acidic conditions. When an elimination happens in acidic conditions is because we start with an alcohol, and if we have an acid, for example, we can have hydronium ion. What will happen is that the lone pair on the oxygen will grab the hydrogen, and then it will become an excellent leaving group. And notice that once you form the hydronium and one of the protons is taken by the alcohol, then what you will get is water. And water can act as a base now and deprotonate one of the hydrogens. So for example, these ones right here. And when the water comes, the protonates, collapses, and then the leaving group leaves. So let's look at two examples of acidic eliminations or elimination in acidic conditions. So the first thing that will happen here is we have concentrated H2SO4. That's a very strong base, a very strong acid. And usually when you have H2SO4 in water, this is going to be very common. The first thing that is going to happen is that you have here the sulfuric acid right there, plus the water. The first thing that will happen is that the water will get protonated, and then at that point you will form HSO4 minus, that I'm not going to redraw the Lewis structure, plus hydronium. And then the active species and the species that is going to react is that hydronium. So now let's look at the actual reaction and what actually happens. So imagine we have this reaction, and that is as if you had that alcohol reacting with a hydronium. I just explained why in concentrated H2SO4 or in you will see H2SO4 in water, how you get that hydronium. I won't explain it again. I would assume that every time that you have sulfuric acid and water, you form that hydronium ion. So first, the lone pairs on the oxygen will grab one of those hydrogens. Now we will have a very good leaving group. It's positive, so when it leaves, it will become water and it will become neutral. And now I have another molecule of water that formed here when it left that can come and grab any of the 9 hydrogens, right? Because they are all the same. You have 3 here, 3 here, and 3 here. Now it can come. The electrons will come back down and form the pi bond, and the leaving group will leave. And so that's how we get that alkene, plus we regenerate H3O plus right here, right? It forms again. So now this molecule can start over and so on. So that's how this reaction progresses. Let's look at another example. This one is a little more tricky because I want you to notice something. In the starting material, you have 3 methyls on one side and 1 methyl on the other side. In the product, you have 2 methyls and 2 methyl. This is a sign of a rearrangement happening. Right? And that happens because we will go through our carbocation that has a positive sign, and it can rearrange to give us a more stable carbocation. So let's see how this happens. First, again, we have H2SO4, so you can assume that H3O plus is the active species that will protonate the water. So that's the first thing that happens always. Then the next step is that water will leave, and that will form this secondary carbocation. Now, remember that this carbocation is not the most stable, it's not possibly the most stable. So what will happen is that one of these methyls will move around. If we had a hydrogen, the hydrogen will move around in a hydride shift, but because we don't have any hydrogens here, it has to be an alkyl shift. Now, what will happen is that this molecule will form and we end up with the plus right there. And we still have water, and we need to identify the beta hydrogen. So in here we have, this could be a beta hydrogen right there, or this could be a beta hydrogen. We have one right there, and we want the most stable one to form, right? So that would be the more substituted. If it were to form here, we will get a disubstituted alkene, but if it forms right here, we will get a tetrasubstituted alkene. So now the water can come, that will form the alkene right there, and that's how we get the final product, plus H3O plus that regenerated.